Hi, this is Leslie Langno with Make Parts Fast here at the Rapid Plus TCT show, and I'm here at the XJet booth with Dror Danai, and we're going to go over a little bit about how your technology works and how you're able to create such an intriguing part. So tell me a little bit about how your process works.
Well, it's nice to start with the part and then we go backwards and try to understand how it's becoming possible. This part, although it's a few inches tall, it's a drill, and it has more than 2,300 conformal cooling channels. Each one of them is less than 200 microns in diameter. Now, how is that possible? And that takes us back to the technology. This is the only technology that is using direct jetting. It's the only technology that jets the material itself. We jet metal or ceramic, we can do either or in a very similar way on the same machine. What we do is we use thousands of nozzles. Half of the nozzles are used to jet the build material, whether it's ceramic or metal, and half of the nozzles are used for support. The support structure is what allows us to make virtually any geometry.
Now, is the support material that it's jetting?
Yeah, we jet the support material. Now, the support material is from totally different family of materials. So the beauty with that is that in a very simple, not to say trivial process, we remove the support when the part is ready. And this allows us to make these small, tiny holes that are not even straight, And this allows us, because what we do, we don't put anything actually. The software generates the support structure for whatever geometry you need, and everything that has support will be removed easily in a simple homemade solution after the part is printed, which means that it's almost dissolved away. What we do, we take nanoparticles of ceramic or metal and we suspend them in what we call ink. It's a formula, a carrier, a liquid carrier that we create. We jet the carrier with the tiny particles that are submicron, and we keep very warm temperature to allow almost immediate evaporation of the carrier. And then we're left with a layer.
Now, is it any kind of metal material?
We have two materials on the same machine. It's based on the same technology. We have the zirconia, which is already installed recently, and later this year, we will start ship machines that jet stainless steel. And that's the beauty of inkjet, is that you have the ability to suspend different nanoparticles in liquid, which we call ink. Now, it sounds easy. In reality, each materials take us months to develop the ink and then months to test it. We hope as the company grows, as we are more spread around the world, we will be able to bring few materials on an annual basis. But
how do you get the nanoparticle of metals? How do you get the metals to be nanoparticles?
To begin with, we start with relatively small particles, and then we apply a few techniques to make them even smaller. The nice thing about that is that we are not limited by the size or the shape of the particles. So unlike all the different technologies, great technologies on this floor,
especially for powder metal,
they look for powder metal that will be extremely precise and uniform in distribution. We don't need uniform distribution. Actually, we need a broader distribution. For ceramics, it can be from 20 to 80 nanometers, for example. And we do not care, and actually we like that the shape of the particles will also be stochastic or random, meaning different shapes. Now, the beauty of the different shapes is that at the moment that it hits the tray or the previous layer, it's spread, and somehow with the carrier, before it evaporates, it's a microsecond, but in this very short period of time, the parts form a perfect puzzle. And that's why after you go through the sintering, you get a layer, and later on a part that has no porosity. We're talking about, in this part, 99.95% density. But it doesn't stop with the density. Because we're using variety of sizes and variety of shapes, we call that natural packing. Because if we do a slice and go to an electronic microscope, you will not be able to tell if that was made on normal zirconia in traditional ways or on our technology. And this is not trivial for additive manufacturing. So we have more and more results now that show that when you look under the microscope, you wouldn't be able to tell what was made on a normal metal, molten metal, or nanoparticle jetted parts.
So for an engineer who wants to find out more about the XJet technology, where would they go to?
Well, I guess the best way today is to go to XJet3D.com. XJet3D.com. We keep it updated. Also, soon there will be some customers' stories and case studies. So I think that's the recommended way to find more information.
Perfect. Thank you so much, Dror. I appreciate it.
I appreciate that.
Alrighty.
Thank you.
And that's what's going on here at Rapid plus TCT.